this is fixable. We're going to wood glue this later. And that stays in. So we're using this cut regardless. Cool. So let's dive in. Okay, there we go. So the theory of measurement we're introducing here has been called, oh, come on, slides, show me. Okay. Has been called the classical test theory because it was developed from really simple assumptions made by test theorists since the inception of testing. So we're not talking like Han Dynasty inception, we're talking like early 20th century. So the techniques we're using here for classical test theory are about 100 years old. So in comparison, the book is a spring chicken in comparison, I guess. But anyway, so this approach is also called the theory of true and error scores. So let me just ease us in here. So from the perspective of the creative thinker or innovator, consistency can be viewed as problematic. Consistent thinking leads to more of the same as it limits diversity and change. However, inconsistent thinking and thinking outside the box, while it produces new methods and ideas and innovation, it does all these lovely things. However, standardized tests are designed to be consistent and by their very nature tend to be really bad and ineffective at measuring things that are supposed to be inconsistent. Like creative thinking, for example, which I think I've talked a little about in this class, but so while consistency is not so great in many areas, in testing we really need it. So, yeah, cool. So it's actually one of the biggest white whales in testing, fun facts, because it's the hardest to measure, and yeah. But that's a little bit of an aside. But in testing and measurement, so from the perspective of the test maker and test taker, which happens to be the perspective we're taking in this class, consistency is critical to valid measurement. An inconsistent or unreliable test produces unreliable results that only inconsistently support the intended inferences about the test. And nearly a century of research, frankly at this point it's more than a century of research, provides us with a framework for how to examine and understand reliability of test scores, and most importantly, how reliability can be estimated and improved. So this module is going to introduce reliability eventually, but within that framework of classical test theory, which is then extended, we'll extend this to kind of generalizability theory, and eventually in later modules, we're going to learn about reliability within the context of item response theory modeling. And that's a slightly more modern innovation, probably 1930s, 1940s, super advanced techniques we're talking about here. But anyway, that's enough about the history. So all of these theories, all of these different models involve a measurement model. Now, sometimes these are referred to as latent variable models. Those latent variable models are used to describe the construct or constructs assumed to underlie responses to test items. But we're not there yet. So we're going to start with a general definition of reliability in terms of consistency of measurement. We'll talk about the classical test theory model and assumptions we'll kind of link those to statistical inference and measurement. And we'll talk about reliability and unreliability, especially standard error of measurement. Eventually, possibly in the next module, depending on how much time this takes, we'll talk about 4 main study designs and corresponding methods to estimating reliability. And finally, we'll talk about reliability for situations where scores come from raters. And This is called inter-rater reliability and is best conceptualized using G-theory, which we'll get to. But that's the roadmap of where we're headed. But to start, I'm going to talk about precision of the measurement process. So in education and psychological testing, reliability refers to the precision of the measurement process, or the consistency of scores produced by a test. So reliability is a prerequisite for validity. So in other words, for a score to be valid, for a score to actually measure something truly, it first needs to be reliably and precisely measured. But even if you have that reliable measure, that doesn't mean you have a valid measure. For example, I could use a ruler to consistently measure IQ. Now, great. How would I do that? Probably some phrenology type thing, but it would be very consistent. I would have 1 foot of IQ, I guess. However, that doesn't mean it's a valid measure. Just because it's consistent doesn't mean it's valid. But you need consistency in order to have validity, which is one reason why creativity tests are like the white whale of testing. All right. So just to give you kind of a nice, simple analogy that might help clarify this distinction between reliability and validity, because frankly, this is one of the big important things that if you don't get this idea now, you're going to really struggle through the rest of this class. And so I'm going to emphasize this. Please know this for the test, because I will ask you a question about this. I might even ask you to come up with a new analogy. But here's the analogy that everyone loves. So think of the testing process like an archery contest where the test taker is the archer and they get multiple attempts to hit the center of a target. And so we can think of each attempt, each arrow, as a repeated measurement of the construct of archery ability. So imagine someone whose arrows all end up within a few millimeters of each other. They're really tightly bunched together. But they're stuck in the trunk of a tree behind the target. Yay, that's super reliable, right? Not so valid. So, on the other hand, consider an archer whose arrows are all over the place, around the target, one hitting really close to the bullseye, and the rest just all over. So, this inconsistent scatter shot represents measurement that is inconsistent and inaccurate, though more accurate than perhaps the first archer, because at least you did hit the target once. So that's something. Now, reliability and validity can only be present when all the arrows are close to the center of the target. So in that case, we're consistently measuring what we intended to measure. So a key assumption here in this analogy is that our archers are actually skilled and any errors in their shots are due to the measurement process itself. So instead of, we could think of consistently hitting a nearby tree may be evidence of a reliable test given to someone who simply is missing the mark because they don't know how to aim or where to aim. So they could be giving us good results, but to the wrong thing. So in reality, if someone scores systematically off target or above or below their true testing ability, we have a really hard time attributing this bias to the testing process versus a true difference in ability. All we know is that they are performing poorly on the test. We don't know why. But let me keep going, because I know that y'all have places to go and other YouTube videos to watch. So a key point that I'm trying to get across here is that the evidence supporting the reliability of the test can be based on the results of the test itself. However, evidence supporting the validity of a test, so that in this analogy, that's the bullseye itself, must come in part from external sources. So the only way to determine if that consistency of hitting a tree represents low ability is to confirm, first of all, that the test is unbiased and to conduct separate tests. These are validity issues, and we will get there. But to make sure that we can kind of evaluate validity, we first need to hit at reliability. But we'll get there. All right. So, another example would be like, consider the reliability of familiar physical measurements. So one really popular example is measuring weight. How can measurements from a basic floor scale be unreliable or invalid? So think about potential sources of unreliability or invalidity. So consider the measurement of, so the example I've written here is of a kid, but I'm going to change it up because I like making my editing job more difficult. So consider measuring the weight of a cat every day before school. So what are some of the variables we're actually measuring? Frankly, how the hell are you going to do that? Why is this cat going to school? There's so many bigger questions. But like, how might this variability change from day to day? And how might these changes be reflected in our general measurement? So if our measurement changes from day to day, how much of that change can be attributed to general actual changes in weight or extraneous things like the weather or glitches in the scale, or just the irritability of our cat subject? All right. So, sources of score change, what we're going to be talking about. So in both of these examples, there are multiple interrelated sources of potential inconsistency in the measurement process. So these sources of score change can be grouped kind of into three broad chunks. So the first is that the construct itself may actually change from one measurement to the next. So for example, like, think of practice effects or growth. These can lead to improvements in performance over time. So an archer may shoot more accurately as they calibrate their bow or readjust for wind speed with each arrow. And so in achievement testing, students may learn. Shocking, learning in achievement? Oh no. Or at least be refreshed in the content of a test as they take it. Essentially, you're reminded what you're learning about learned about. I imagine that if I had to take an intro stat test right now, I would probably do pretty roughly on the beginning because I haven't taken a test in a while. Ooh. Okay, so that's one. Number two, the testing process itself could differ across measurement occasions. Say there's a strong cross breeze on one day in our archery contest, but not the next. And we actually see this a lot in Olympics, where they it's kind of luck on where you end up. Hello, Annie. Hi. You want to come here? Maybe? Are we thinking about? Nope. Sorry. Annie, our who really should be the star of this class, because she's named after the textbook author, is she's okay. So let's go back up. So second, the testing process itself could differ across measurement occasions. So maybe we have a strong cross breeze, or maybe people officiating our competition allow for different amounts of time for warm-up. Or maybe our audience is grumpy or disagreeable at some point and supportive at others. So these factors are tied to the testing process itself, and they may actually lead to changes in scores. So you can think about this like during the sports process, that there's like a home field advantage effect, things like that, allegedly. That would fall into the second category. Now, third, our test may simply be too limited in scope. So despite our best efforts, maybe that these arrows differ from each other to some degree in terms of balance or construction or even like feather type. Or maybe it's just that the archer's fingers slip for no fault of their own. By using a limited number of shots, scores may change or differ from each other simply because of the limited nature of the test. So extending this analogy to other sport ball type things, football, basketball, each involve many opportunities to score points. And those could be used to represent the ability of a player or team. On the other hand, like in soccer or football, for everyone outside of the colonies, a single match may not accurately represent ability, especially why would I write? Especially if the referees have been bribed. I don't know why I wrote that there, but I did. So consistency is important, is what I'm trying to say here. So we're wrapping that up. It's kind of a necessary condition before we can even talk about classical test theory, which is where we're going next.